Right now, we will talk about in reference with numerical solution of ordinary differential equation by Runge-Kutta method of fourth order. So actually, the Runge-Kutta method is a general method for numerical solution of ordinary of differential equation such as Euler's method, Euler's modified method, or some particular cases of Runge-Kutta method. So this is in the fourth order, and right now we will start and let's see the given differential equation here. So there's this method. Let's see the given differential equation b as dy over dx is equals to f of x and y with initial conditions in which y is equals to y naught when x is equals to x naught. Then, to find the value of y minus y naught plus k at x equals x naught plus h, we need to calculate the following terms. What are these terms? So this one are our k terms. The k1, the formula for this is k1 is equals to h into f of x naught and y naught. And then the second term is k2 is equals to h into f of x naught plus h over 2 and y naught plus k1 over 2. And you can see here there's a k1, so probably or we need to get first the k1 before we can proceed with our solution in k number 2. So next is for the K3. So the same thing, this is a continuous equation. As I have said, we need to get the first one, K1, and as you can see here in the K3, we need to get the K2. So the same thing, it's K3 equals h into f of x naught plus h over 2 and y naught plus k2 over 2. So next, we need to find out the fourth one, lastly, which is h into f of x naught plus h and y naught plus k3. So basically, we already have this k1, k2, k3, and k4. And lastly, we need to find k, and k is equals to 1 over 6 times the k1 that we get in here, the previous equation, plus 2 times k2 plus 2 times k3 plus k number 4. So then we need the required value of y. So given by y is equals to y naught plus k. So we will be already given here the y naught, and then k we will find in this form, this k number 4 here. As you can see, yeah, we need to, or k will find in this form, which is the previous equation that we had. So we can give the value as y is equals to y naught plus k, right? So right now we need to find another example, or we need to solve example given here in this formulas that we had. Alright, so moving on to the examples here. Okay, I will read it aloud to you. For example, apply Runge-Kutta method of fourth order to find the approximate value of y at x is equals to 2 if dy over dx is equals to x plus y squared, given that y equals 1 when x equals 0 in steps of h is equals to 0.1. So now we have to find y. We have to find y at with x with the value of 0.2, right? So this is the question here. So let's apply, in this case, let's apply the 6th-RUNGE-KUTTA method of fourth order. So we need to have a solution here. So supposedly, we need to find out the f of x, which is, let me see, it's f of x naught and y naught is equals to x naught plus y naught squared. We supposed to get this one. So we need to substitute the value of x0 since we have here the given, which is x is equals to 0, so we just need to substitute, and y1 is equals to 0. So we have a solution here, which is dy over dx equals x plus y squared, and we need to have f of x and y is equals to this one, x plus y squared. So we have the given value, as I've said earlier, we have the given value of x naught, which is a 0 as we have, and y is equals to 1 with, and also h is 0.1. So we just need to substitute, of course. So f of x naught, y naught is equals to x naught plus y naught squared is equals to 0, which is our value here, plus 1, which is our value of y is equals to 1. So now we need to find the k. We have the formula here, k1 is equals to h into f of x naught and also y naught. Then just substitute the value of the given value, right? So we need to substitute here in which we have h 0.1, and then we have also the one that we have find here from our f of x naught and y naught. So we find out that k1 is equals to 0.1. So next we need to have k2 as well. Since this is for fourth order, we need to proceed for the second equation that we have. We have the formula k2 is equals to h into f of x naught plus h over 2 and y naught plus k1 over 2. So simply we input the details, our value here of h, which is 0.1, and our f of x naught is 0, and our h is 0.1 over 2, and then substitute the y naught 1 plus 0.1 over 2. So we get here the value of 0.1 f of, let me see. So now we have here 0.1 f of 0.05, where x naught, and then y 1 plus 0.05. And also we have here, substitute from here, we have 0.1 into f of 0.05, and this one is 1.05. Now this one here that we come up with this answer in here, this is in the form of xy, and we have to find the f of xy since f of xy is equals to x plus y squared, right here, which is f of xy equals x plus y squared. So this is in the form, right? So we can use the value here. We can use that value here. So we have 0.1 times 0.05 plus y squared means plus y squared. Look at a given example here. It's y squared. So we need to square this one, which is 1.05 squared. So we get that k2 is equals to 0.11525. Alright, so we need to proceed since we already have the second k. And we have the next is k number 3. So for k number 3, we need also to substitute all the given values we have, which is h 0.1 into f of x naught, with a 0 plus 0.1 over 2, and also 1, which is our x naught, plus 0.11525, which is our k2, and divided by 2. So we get here, if we substitute all those values, we get our k3. We need to input here in our calculator, which is 0.11686. So this is our k3. And after this one, we have here our approximate value. So after the approximate value, we have y, which is 0 and 1, and also, no, that's not the answer right here. Let me see. Just a second. Okay, right. We need to actually continue to number 4, since this is already, we already have the 0.11686. So we have k4, which is our formula, h into f of x naught plus h, and y naught plus k3 is equals to, our h is is 0.1 into f of x naught, with is 0.1, and y naught is 1, plus our value here for k3 is 0.11686. So let's see, we have already we come up with an answer, 0.13474. So this is our k number 4. So right now we already have this idea of k number 4. So finally we need to find the k, which is our last formula we have earlier, which is 1/6 times k1 plus 2k2 plus 2k3 plus k4. So we have 1/6. Our k1 is 0.1 times 2, our value of k2 that we have solved earlier in the equation, and plus 2 times k3, which is 0.11686, and the k4 that we have is 0.347, number 4. So we get the value of k, which is, we have 0.1165. So 0.1, the approximate value of y, this is what I've mentioned earlier. The approximate value of y is equals to y naught plus k. So we have our y naught is 1, plus our k, which is 0.1165, we get 1.1165. So, but our original, so we come up here, this is our y of 0.1 is equals to 1.1165. But the question is, our original question was, we have to find y at x equals 0.2, and we got here a value for 0.1. So we are not yet being done here in solving the equation. So we have to do this procedure again by using the same formula that we had. So we have y at x is equals to 0.2, since this is our main original question. So we have for x naught, which is 0.1, here our x naught, and our y naught is this one, 1.1165, and also we have the value of h earlier, which is 0.1. So we need to just input all the values that we have. We have the f of x naught and y naught equals x naught plus y naught squared is equals to 0.1, plus our y naught, which is 1.165. So we need to square that one, since this is the formula in here. So we get f of x naught and y naught is equals to 1.3466. All right, and we need to substitute. So after getting the f of x naught and y naught, we need to proceed to find out the k's, which is k1, k2, k3, and k4. So we input the details here. Our k1 is h into f of x naught, y naught. So we are having 0.1 again times 1.3466, which is our value here of x naught and y naught. So we come up with the answer of 0.13466. This is our K1 here, and let's proceed to number K2. Our equation for K2, which is h into f of x naught plus h over 2, and then y naught plus k1 over 2. So we input all our answers. We have our k1, which is we found earlier as 0.13466. So we substitute all the values and we get k2, and this is the answer for k2 until our K3 is also, we need to have this formula and substitute the value again from K2 since we have a K2 here. So we have to get a K3 of 0.15758. And then the last one, which is our K4, is equals to h into f of x naught plus h and also y naught plus k3. So we have here 0.1 f of 0.1 plus the remaining values here. We get the k4, which is 0.18233. So now we already have the four K1, K2, and K3. Let's find the K. Our formula for K again is 1 over 6 plus K1 plus 2K2 plus 2K3 and plus K4. So we substitute the values that we have here earlier. So we find out that our K is equals to 0.1571. So you can just check that there in your calculator as well if this is correct, but I will believe it's correct since I'm using my calculator also. Okay, so this is our K now. So the approximate value of y is equals to y naught plus k. We need to have substitute this informations here. This is 1.1165, which is our y naught, and our k that we found here is 0.1571. So we get our y is equals to the answer of 1.2736. So this is why our y into 0.2 is equals to 1.2736. So basically, our question was our question is we need to find y at x is equals to 2. So we have here an answer y at x equals 0.2, and we found our answer here as 1.2736. So we already get the answer, the final answer 1.2736. So that is our fourth order method. So this is how you go through with our Runge-Kutta method of fourth order. Thank you so much, and you do have a great day today. I hope you take down notes in here as well. Bye.